Welcome to the Solocast of Fire Code Tech. In these episodes, it's just going to be me, your host, Gus Gagliardi. There's going to be a range of topics, but I'm going to talk about specific technologies, installation standards, codes and how they work, as well as some other interesting topics that don't neatly fit inside of the context of a normal interview. Hello all, welcome to episode 43 of Fire Code Tech. In this episode, we're talking about fire hydrants. Yes, I believe fire hydrants is a great topic for a Solocast because, like many things that reside in the intersection in between two engineering disciplines, oftentimes they are forgotten or poorly designed. So I'm talking about the fact that fire hydrants, although they are usually designed and located on the civil drawings, have impact to fire protection features for the fire and life safety system. So in these little nooks and crannies between disciplines, oftentimes we can find that projects either forget or neglect to give proper attention to these pieces of equipment. So if you're still wondering if you want to listen to this episode, we're going to talk about codes, standards, and other criteria pertaining to fire hydrants. We're going to discuss the system, architecture, and component pieces of fire hydrants and the piping networks that they are attached to. And also, we're going to get into some key definitions for what a fire hydrant is and the different types of fire hydrant. I wanted to take a moment and talk about the codes and standards up at the front of this episode. The goal of this episode is not to discuss the codes and standards. I really wanted to just discuss some entry-level topics to establish what a fire hydrant is and some of the parts and pieces of this piece of fire and life safety equipment. But as a foreword for the people who may have been listening to hear about more criteria or codes and standards around this subject, I'll start off with the codes and standards surrounding fire hydrants. If you're working in the U.S. and you're using the International Family of Codes, you can look in the International Fire Code for additional code excerpts for the requirements for fire hydrants. The section specifically in the International Fire Code 2021 edition is 507.5.5. This section is titled Fire Hydrant Systems, and it is not very long. If you want to go brush up on these codes before you design a project, it'd probably be a pretty good idea, as the codes are always a magnificent place to start to make sure that you are at the very minimum getting the code required features that are in place in your project. Second, let's talk about in the standards portion of the codes and standards discussion, where would you go to find out more criteria about fire hydrants? One place you could look would be N FPA 24, which is titled as Standard for the Installation of Private Fire Mains and Their Appurtenances. The chapter in specific where you can find information about fire hydrants is Chapter 7. Moving forward to the inspection, testing, and maintenance criteria for fire hydrants. If you want to find this sort of information, go ahead and go look in NFPA 25. Strangely enough, this is also in Chapter 7, but the name of the chapter is not fire hydrants like it is in NFPA 24. It is Private Fire Service Mains. Okay, just for a quick recap, we talked about the codes section in the International Fire Code. We talked about the installation standard, which is NFPA 24. And then we talked about where you could find the inspection, testing, and maintenance criteria, which is NFPA 25. As an additional point about criteria, there is an appendix in the Fire Code, which is Appendix C. And this appendix is named Fire Hydrant Locations and Distribution. Just a note on appendix material, you may know, but just worth saying in this discussion that appendix material is not always adopted, so you have to check your specific jurisdictional criteria to see if this appendix material is adopted and pertinent to the project that you're working on. But it's good to know about the criteria into this appendix for best engineering practices. Okay, moving on, I want to talk about the definitions portion of this Solocast. So what is a fire hydrant? Maybe I should have put that first, but I'm going to leave it here anyways. What is a fire hydrant? Let's talk about the definitions, which can be found in N FPA 24. Hydrant can be found in the N FPA 24, Chapter 3, and it is defined as an exterior valved connection to a water supply system that provides host connections. So my 2 cents about this is that hydrants come in different colors, and sometimes they can be indication of different factors for the hydrant or for the facility, whether it be private or public. And some of these factors may include how much water supply is available from the hydrant, the water supply source in which the hydrant is fed from, and also it can just be a coloring or designation system for the facilities or base criteria. So there are 2 big main types of hydrants. One is a wet barrel and one is a dry barrel. I'm going to talk about the definitions for both of these. Let's start off with dry barrel. Dry barrel hydrant is described in 3.4.1.1, and it states a type of hydrant with the main control valve below the frost line, between the footpiece and the barrel. Dry barrel is the more common of the 2 hydrant types. This is going to be found anywhere in which you would normally have freezing conditions throughout the year. So in the majority of the US, this is what you're going to find is dry barrel hydrants. Well, I bet you can guess what the next definition I'm going to cover is. That's right, it's wet barrel. And so this definition is 3.4.1.6, and it is stated as a type of hydrant that is intended for use where there is no danger of freezing, weather, and where each outlet is protected with a valve and an outlet. My piece of information on this wet barrel definition would be that these hydrants are only common in very select pieces of the U.S. Think California and Florida in specific ranges where the weather and or climate is exceedingly temperate or tropical almost. And so outside of the U.S., think of the Caribbean or other geographies that are near the equator. Moving on, let's talk about the different component pieces of a typical fire hydrant. So we're going to start off talking about the actual hydrant, and then we will also discuss the piping and valving that leads up to the hydrant. So for a brief overview before we dive into this different pieces, the summary of the pieces are the hydrant body, the stem nut or the operating portion of the hydrant, the bonnet, the side outlet, the pumper outlet, and the base flange. Let's go from the top of the hydrant down to the base flange. And so the first piece we're going to talk about is the operating stem and nut. This piece is on the top of the hydrant, and it is how you open and close the fire hydrant. You can use a hydrant wrench to do this operation. Next piece we're going to talk about is the bonnet of the fire hydrant. Think of this as the round domed piece at the top of the fire hydrant. Of course, there are some types of fire hydrants that will have different configuration that are not domed, but the top component of the fire hydrant. Sometimes the hydrant cap or bonnet can be a different color than the body of the fire hydrant. So it's good to note these details if you are doing a survey of fire hydrant or you are doing a flow test and you want to provide documentation of the hydrant in which you are activating. First outlet we are going to talk about is the side outlet. So there is the pumper outlet and the side outlet. The side outlet is one of the 2 outlets that are usually 2.5 inches. 2.5 inches is the standard hose size connection. Another standard hose size connection is 1.5 inches. The other connection is the pumper outlet. This outlet is usually 4 inches, and you can hook the larger lines up to this outlet. I guess that makes sense since it's 4 over 2.5 and 1.5. But you can get a much larger volume of water out of the pumper outlet. The flange, or the base flange for the hydrant, connects the hydrant to the piping that extends all the way down to the elbow at the bottom of the hydrant stem. Only other component we didn't talk about for the hydrant within the hydrant is the stem. And the stem is what raises and lowers the plunger-like device to allow the water into a dry hydrant. That is what operates when you are turning the stem and nut at the top of the hydrant. Let's talk about the components that lead up to the hydrant and some of the piping and valving. For a brief recap, we talked about the stem and nut, the bonnet, the side outlet, the pumper outlet, and the base flange, as well as the stem within the hydrant. And now moving forward, we're going to talk about the gravel and drain basin, the thrust block, the control valve, and what the terms lateral or branch line and service main or fire main mean in the context of a fire hydrant. First up is gravel and drain basin. This is the area in which the dry barrel hydrant drains into the ground. Interesting note, you can put your hand up to the side of the side outlet if you have all the other outlets with their cap on them and feel the suction from the hydrant draining. If you've done a flow test and you are waiting for the hydrant to drain or verifying that the hydrant will drain, that's a good trick to know. Thrust block is a restraint or a restriction of the hydrant, and there is a calculation for how to determine the size of the thrust block. So that is something to consider. There are specific construction details for how these have to be built as well. The compaction and the aggregate and the concrete around the thrust block so that the pipe is restrained and supported correctly. Control valve. The control valve is required for the fire hydrant for you to be able to isolate the fire hydrant, maintenance on the fire hydrant, or if somebody hits a fire hydrant with their vehicle, so you can turn off the fire hydrant. Lateral or branch line for a fire hydrant. This is, the military refers to it as a lateral line or a lateral service. So service lateral. Think of this as the specific piping that serves the hydrant, not the main that serves multiple hydrants. Next is service main or fire main, which this is the component that, think of a sprinkler main, how it serves the multiple branch lines. This is the same type of interaction in the piping system. I think that's going to do it for this episode of Fire Code Tech. Hope you enjoyed the Solocast. As an overview of the episode, we talked about a highlight of codes, standards, and other criteria. We talked about some key definitions for fire hydrants. Last but not least, we spoke of the parts and pieces of a fire hydrant. Hope you enjoyed the episode, and we'll see you next time. Thanks for listening, everybody. Be sure to share the episode with a friend if you enjoyed it. Don't forget that fire protection and life safety is serious business. The views and opinions expressed on this podcast are by no means a professional consultation or a codes and standards interpretation. Be sure to contact a licensed professional if you are getting involved with fire protection and or life safety. Thanks again, and we'll see you next time.